Hello everyone, welcome back to Piece of Physics. In this particular video series, I am going to start our new topic which is differentiation. Okay, so in differentiation we will learn about what is function and how to differentiate any function which is dependent on the another variable. Okay, before starting differentiation, we should have some basic idea about function. Okay, so first of all, what is function? So basically, function relates between two variables. Okay, so So in these two variables, one variable is dependent and another variable is independent, right? So I can have one example of this function as y equals to f of x. Okay, so here I can read this function as y is some function of x. So here y, so here y is dependent on the x, while x is the independent variable. Okay, so here I can have one example like y equals to x square plus 1. Okay, so y is some function of x, so I can put y equals to, for x equals to 1, it will have one value which is 2. I will put 1 here, so 1 ka square is 1 plus 1 equals to 2. Okay, so let us have one another example for x equals to 2. Okay, so I'll put 2 here, so 2 square is 4 plus 1, which this will be 5. So here you can see x can take any value, so it is independent, and y is dependent on the x. Okay, so this is what function is. Okay, one another example is y equals to sine of x. Okay, for x equals to 30 degree, y equals to sine 30, sine 30 is half. For x equals to 60 degree, y will be equals to root 3 by 2. Okay, so here you can see that y is dependent on the x. Okay, so x can take an so x can take any value which is not dependent on the y. Okay, so this is all about function. Basically you should remember that function is just simple concept. Function is so basically you have to just remember that function relates between two variables, one is dependent and another is independent. Okay, now let us move to the differentiation. So what is differentiation? Basically differentiation is rate of change of dependent variable with respect to independent variable. So from our from the example of function, we can have dependent variable as y and independent variable as x. So the differentiation of y with respect to x, I can write it as dy upon dx. So I can put y prime. Okay, so y prime means I have done differentiation of y with respect to x just only once. Okay, if I differentiate it again, so we will have d square y upon dx square, which is basically dy by dx of dy by dx. So basically I differentiated y once with respect to x. Again, whichever quantity I get, I will differentiate again with respect to x. So basically this is double differentiation of y. Okay, so here we can say that key. So here we can say that in the differentiation we just measure the rate of change of dependent variable with respect to independent variable. Okay, so now let us apply this differentiation to the our physics problems, right? Okay, so what is velocity? Velocity is basically rate of change of displacement with respect to time. Okay, so I can put velocity v equals to dx by dt, where v is the velocity and x is the displacement. Okay, so basically this is time derivative. D by dt is our time derivative. Okay, so I can put v equals to x dot. Okay, this dot represents differentiation with respect to time. Okay, similarly I can put speed v equals to dx upon dt, where x is the distance. Okay, so differentiation of distance with respect to time will be our speed. Okay, now our another quantity is acceleration. Basically acceleration is rate of change of velocity with respect to time. Okay, so I can put acceleration equals to dv upon dt. Okay, so basically acceleration is just time derivative of velocity. Okay, again I can put d by dt equals to into dx by dt. Okay, so this will be d square x upon dt square. Okay, so here acceleration is 2 times differentiation of displacement with respect to time. So I can put a equals to x double dot. Okay, and also I can put a equals to v single dot. Okay, so this is all about how we can apply our differentiation to the physics problems. Okay, now let us move to the geometrical interpretation of differentiation. So in the geometrical interpretation of differentiation, consider this graph of y versus x. Okay, so here y is some function of x which can be represented by this pink line. Okay, so if I take 2 points here and here, so we can have one right angle triangle like this. Okay, so this part basically is the change in the y-axis quantity, so I can put it delta y, and this base basically represents delta x. Okay, so here I can have rate of change of y with respect to x as delta y by delta x if x approaches 0. Okay, for that case I can make one small right angle triangle here. Okay, so this height will represent dy and this base will represent dx. Okay, so in case of x tends to 0, delta y will be converted into dy and delta x will be converted into dx. Okay, so under the limit delta x tends to 0, delta y by delta x will be converted into dy upon dx. Okay, so here dy upon dx is majorly one kind of slope of the line. Okay, also if y increases with increase in x, so dy by dx will be greater than 0. If y decreases with increase in x, dy by dx is less than 0. So this is all about how I can represent differentiation using the graph. Okay, so here we can just say if the value of x is too small. Okay, here I can take value of x is nearly equal to 0. Okay, this means x is nearly equal to 0, but does not equal to 0. Okay, so the value can be around 0.0001. Okay, so in this case our under the limit delta y by delta x will be converted into dy by dx. Basically that thing is our differentiation. Okay, so this is all about differentiation's basic introduction. Okay, in the next videos we will learn about how to differentiate different kind of functions and equations, all these things. Okay, so stay connected to the channel. Thank you so much.